Alright, guys, we're going to get started here. People will probably still be trickling in the labor, that's fine. So, first, as always, thank you guys for coming. Decent turnout today. We know as part of these groups that it gets harder to have people show up as the weather gets warmer, but it's still cold in Russia, so we gotta keep up on things. The rules. Number one, as always, don't be a dick. Tonight especially, we're gonna have lots of people up here, probably for the first time, getting to talk in front of a group like this, sharing their security knowledge, just a few minutes. Be respectful of that. We're all here to learn. We're all here to build a network. At the same time, don't take yourself so seriously. We're all trying to get a little unwound after work and get some stuff done here. That's what we're here to do, amongst friends. So don't have to be all uptight. And also, tonight is your first night at CleveSec. I think we may have one or two first timers out there who will have to speak. Tonight's question is a taco a sandwich? Please make your case. So, before we get into that, where do we live quickly? Twitter. Twitter is the social media outlet of choice for most security people, I think, but also us. At CleveSec, you can reach us pretty easily there. Hashtag CleveSec, we try to watch that. And if you put anything on hashtag CleveSec, it'll likely end up retweeted by us. We'll try to put things out there, job postings, project you're working on that you need help with, something you want the community to know about, go ahead and use hashtag CleveSec. It's there for you. Meetup. Meetup is where you'll get all of the relevant info regarding our meetings, regarding where the meetings will be, what time we'll start, what the content will be, who the speakers are. Our members are all listed there. If you need to contact one of them, you can go ahead and do that. We also have some files listed from the forums, and there's a file distribution center for maybe handouts given out after a talk. Sometimes speakers upload their presentations there. All kinds of good stuff on the meetup. Go ahead and take some time there. We have an obligatory LinkedIn group. There is absolutely nothing happening on there, and there probably never will be. But if you want a logo at the bottom of your LinkedIn page, go ahead and join that group. I would put the URL up here for you, but it's horrendously long. Just search for CleveSec and you'll get it. And if you want to reach us in a less public way, clevesec@gmail.com is the way to do it. If you want to send us a talk, you have a question about something we're doing, you have a suggestion that you want a little bit offline, go ahead and shoot us an email there. We monitor that. We'll get you back to you very quickly. And our meetings are recorded and put up on youtube.com/CleveSec. We've been a little slow about that recently because, I'm not going to lie to you, it's a pain in the ass. But we do it for you, and it's up there now. We're all up to date as it's today. As always, this is a community effort. We couldn't do this without you guys. Without you guys, it would just be Marius here in a hat and myself in this room talking to ourselves, and that would be a lot of fun for anybody, especially the future of our jobs. Second Tuesday of every month, we have our lecture and discussion night, like we're doing tonight. The last Tuesday of every month, we have our community night. Started out as a let's get together and go do something. Ended up as we're going to go drink and complain about security. So if anyone ever gets tired of doing that, we'll do something else. But for now, we go get drunk and complain about security. Check the meetup for locations on that. Always a great time. If you have ideas for community night that is not going out and drinking and complaining about security, please feel free to submit them. Or if you have a place that you'd like to go get drunk and complain about security, let us know, and we'll consider going there and joining you. And of course, spread the word. Bring your friends along, bring people along that might not think that this is their first place to go. Bring your admins, your developers, people that might not have security front of mind. We always love to hear from them. We've had some teachers come out. That's always fantastic. Trade by the mic. Oh, the battery. Guess we're going this way. Okay. So, yeah, just in general, bring some people out that might not have security in front of mind. Go ahead and bring them out, and we'd love to see them and talk to them and get security in there. Tonight's agenda, lightning talks. We have, I believe, 6 or 7 fabulous speakers coming up here to give you 5 or 10 minutes of their expertise on a brief subject. It's going to be a lot of fun. So, before we get into it, let's have our first timers up here. Any first timers make your way on up? Pretty simple. All we'd like is your name, and then tell me if you think a taco is a sandwich. Why or why not?
I'm Mike Woolard, security analyst at OE Connection. Taco is definitely a sandwich.
Hi, I'm Faehnrich. I would say a taco is like a sandwich in the same manner that pizza is an open face sandwich.
No one escapes the Fight Club rule. I know you have strong opinions on this matter. Sorry. That was totally not there you
I'm sorry, I was just so excited. Give you my strong opinions. Taco breaks along with seam of the taco, making two sticky pieces. I believe it is a sandwich, otherwise, no.
go. Strong arguments. Strong arguments from Ms. Mauriello. Thank you. All right. So, since we have so many talks today, we weren't exactly sure how we were going to decide who goes when. But Marius came up with an excellent idea. So, Miss Roxanne Jackson, would you please give me a number between 1 and 10? 7. All right. Here we have a list.
7?
Oh no, don't worry. You're not going first. This is what we're going to do. I'm going to hit this button 7 times. Ready?
And what are the concepts?
1, 2, 3, 4, 5, 6, 7. Oh, he's first anyway! All right, first we'll have Hacking from a MacBook Air by Mr. Warren Kopp, and then we'll go down this list.
Now the real question is, did he make it do that?
I like it. Did they get louder when I put that in?
No.
That's what I think that's what we're
Alright, can I close this or do I leave it open to make it work?
yeah, you can close it. Just don't unplug it.
Alright, cool. Of course you turn it off. Alright, testing. There we go, cool. How many things can I hold at once and still get a talk? So, as Kris said, I'm Warren Kopp, and here's my talk about hacking from a MacBook Air. I do AppSec here at Highland. I really like my job. I do sysadmin stuff for fun at home because I like to take computers apart, and you only have so much fun doing that before you have to learn about software and things like that. I have been, always will be, probably at this point, a Mac guy. Can't read the fine print there. I've passed the test for Assist, but I haven't gotten a certificate, and that test was hard, so I'm claiming it. Like I said, I've always used Macs. That's what I grew up on. The first computer I touched in about 1986 was an original Apple Mac something or another at my dad's grad school. That's where I've always been. Unfortunately, I can't get one at work. But anyhow, and I'm always learning. Lately, that's been AppSec. Everything about AppSec. Where it came from, where it's going, what are the common things, what are the hard things, How do you do it? How do you do it differently? How do you get better at it? And then practice. Everything takes practice. I haven't done anything hard yet in life that I got right on the first try. So, looking at that, where I've been trying to follow is the OffSec model. These guys make a lot of really hard things. They make certifications that are known to be most people failing on their first try. So try harder is a pretty good goal to have. So with that, I need something to practice. And I have constraints. I want to learn things, I want to do stuff, but I have kids. So that right there cuts down my usable hours to about 8.5 a day. I have a full-time job, so there's the other 8 hours. So that gives me about half an hour that a lot of times is yard work, and I need to sleep. So I don't have a lot of spare time, but I have a lot of goals, I have a lot of interests, and I'm trying to get better at them. So last year I bought a computer from somebody who was almost giving it away, which was this MacBook Air. And I learned that I can do all this stuff on the go. It's got decent battery life, it's tiny, it weighs nearly nothing, it has an SSD so it's fast, things like that. But it was a good deal, which means it wasn't top of the line, it wasn't in the best condition, and it's got constraints. It's only got 4 gigs of RAM. Computer programs like to use RAM to run it, and 4 gigs is not a lot. My home machine has 16, my extra machine has 8. This is my portable on-the-go machine, and this is pretty average usage for what's happening with the memory. This is while I was writing the talk, so it's got Keynote, which is like PowerPoint, Safari for research, a few other things, notes, image editors, and it's using up 2.5 out of 4 gigs of RAM. That's no space at all to start doing things in my head. That's what I thought. So, what do? I've got 1.5 gigs of RAM, and I want to practice AppSec things. I want to learn, which means having websites, vulnerable VMs, something running, plus tools, plus research, plus notes, all that. Turns out you can actually do a lot with that. I'm running the most current version of OS 10, which has fancy things they throw in buzzwordy slides like memory compression and stuff like that. I don't know how they work, but I know through the course of working through this stuff for this talk and what I've been doing in my spare time on my mother-in-law's couch, in the corner of a room somewhere, everywhere I end up with a spare 10 minutes where my kids don't need attention, where my house doesn't need attention, where I've got a few minutes to open this stuff up. It's a bigger screen than my phone, and there's a lot more options. So the first place, and I gave a talk about this back before the first of the year here, was vulnerable VMs. Vulnhelp.com hosts tons of ISOs. Many of them are live disks. So you download it, you tell a VM to run it when it turns on, and you don't have to install anything. You have 900 megs, a few gigs worth of storage, and then whatever memory you get. A lot of them have recommendations. A lot of those recommendations are pretty extreme if you have one person hitting it once every 10 or 20 minutes. Even if you're hammering on it, but it's all local. You can fudge these, you can play with them. If you give it 128 megs, it'll probably choke because this isn't 1998, but it's a place to go. And there's tons of stuff out there. People like Apple's. Apple's been selling more PCs every quarter for who knows how long. And people have been writing, converting, rewriting software to work on it. These are just a few that I pulled up that have pretty icons. This is by no means an exhaustive list. People have turned this into a pet project kind of thing. The Proxy.app is written by a group of pen testers in Europe that decided they didn't want to run Java to run Burp Suite or Zap or anything like that. So they built an Objective-C proxy app. It's got rough edges, it's still a 1.0, but it's a good tool. It's fun to learn new things and learn the limitations. So this is before I turned anything on. I've still got Safari, Keynote, have to have Activity Monitor to find this cool graph. And then I turned on some stuff, I started playing with things, all of these things, and it only used up another few hundred megs of RAM, so that was exciting. Turns out you can actually do stuff. So if I've got Safari open, I've never had less than a dozen or 2 tabs in Safari. I've got Keynote open because I'm writing this presentation as I'm testing these thoughts. Activity monitor, proxy, actually proxying information, Wireshark sitting on the interface, keeping track of all the packets that are happening. All of that while talking to this VM that's running on a local interface. Turns out you can do stuff. I was as excited as anybody because when I came up with the title, I hadn't done any of the research. So there's plenty of other stuff, even if web apps aren't your thing. Like Maltego I put here because I didn't realize that was a Java app until I was doing research. But Burp Suite and Zap are intercepting proxies. I'm sure there's other Java stuff out there because what I found doing research for this is everyone uses a different computer with a different OS for a different reason. So Java apps, command line apps, Python apps, Ruby apps, lots of that stuff will move in any direction. From Windows to Mac to Linux to, sure BSD, but I haven't tried it. So there's lots of options. And then my favorite, because I found this a long time ago, is people have ported package managers and repositories to Mac OS. These bottom two Fink and Mac ports, the first time I saw those was in about 2007. And I pulled down KDE and compiled it, which if you've never done that, I recommend it. It's fun to watch a scrolling screen for 3 days. You can pull down these apps. They have lists of apps. Fink and Mac ports now are binaries. Homebrew will search GitHub and add things to their list, their formula list of packages you can just install and keep updated through their app. So you just type brew install SQL map, and then you go brew update, and it looks for SQL map, decides if it has a new version or not, and updates it right there on your system. You don't have to go to Git, you don't have to learn Git syntax. You learn 3 or 4 keywords that work with this brew app, and you're off and running. So, just another set of things that go here, even though I wrote over my own title. Cool. You can install Metasploit. I've seen it. I don't have the interest to do that. I'd rather learn how to build a stripped down Linux VM and run it on that, just because this is my, quote, disposable computer, where if it dies, I'm not going to be too upset because I got a good deal on it. But there's other options. Like I said, you can pull anything you want down from GitHub. Nmap's another famous one. Everybody's used it, I'm sure, at least once or twice to troubleshoot stuff. Even before I learned about InfoSec, I used Nmap more than once to find things on my own network. So there's lots of command line options. And then I just threw Nikto, which is CMS scanner, I think is the best way to describe it. I turned that on. That bumped up the RAM usage because it started beating on that VM pretty hard. But I've got a bunch of tabs, a virtual machine, activity monitor, a packet capture, a proxy with a spider running, and another spider brute forcer, and I'm still not really maxed out the RAM on this machine. So my understanding of memory limits in the course of writing this talk changed very much. I've used this a lot for very specific things, like, oh, I read an article about how to find a directory in a web app, and I had done that. Now I know I can do a lot more. Never to be neglected are browsers and extensions. If you just Google search pen test extension and then a browser name, you're going to find a ton of stuff. People who had an itch that they needed scratched, and they wrote an extension to do it. Shodan does it. They'll do port scans. Now you have port scans that didn't even come from your IP to understand what's running on things. And the list goes on and on. You can deal with HTTP headers. You can change requests. You can alter cookies. All that stuff. It's super easy to find. Someone else has done a lot of hard work that you can just download and use for learning, for testing, for play. And then my favorite part that I started learning about and then reapplying to things is native utilities. This top one, if anybody's used a Mac before, I'm sure you've seen Sherlock, which is their search interface. I think they should call it that. MDFind is the command line version of that. I use this all the time when I'm tunneled into my home machine somewhere else, and I know I have a file somewhere, but I can't remember where. MDFind file name, and it'll give you every hit, just like it would in the UI. It takes options. There's tons of stuff like that buried in OS 10. Console Lab is a pretty decent log viewer. For a GUI app, it's got impressive capabilities. There are wireless diagnostics. There are other diagnostics built in that will tell you things about your connections. And just for a quick demo, if you hold down Option when you're clicking things, a whole new world opens up of what's happening in the OS. This is the Wi-Fi menu. It shows all the available connections. You can scroll down. I had hovered on this one to get the screenshot, but didn't really show any information. But if you hold down Option when you get this, you get the SSID, you get the signal, the noise. If you were connected to it, it would have 3 times this much information. So there's lots of stuff in the OS that's just there to be found, there to be used. Yeah, it was probably built for troubleshooting, but you can use it for learning security stuff too. And then finally, if you're really stuck and you have a slow disk and you have a slow machine and you have a slow connection, download stuff offline and read books. iBooks is a pretty good cataloger manager. It shoots into preview as a PDF viewer. And places like No Starch, PackPub, things like that, they have sales all the time where they give away ebooks for $5 for free. PackPub started one this week that they're running indefinitely where they give away a book a week or a book a day, something like that. They haven't gotten to security stuff yet, but they do it all the time. Over Christmas, I think I spent $20, $25, got 5 new books that I haven't opened yet. I think half of this list. So, worst case scenario, you have kind of an expensive e-reader. That's all I've got. This is where you find me. Questions, comments, concerns. If you want the slides, if you want links from stuff that I brushed over quickly, shoot me a line. I'll help you out. Plenty of people have helped me get to the point where I'm confident enough to come up here and talk. That's what this organization's for. That's why we're having lightning talks and grabbing everybody here. So please feel free to reach out. That's it.
Next, we're going to have XSS, what it is, and how to prevent it by Mr. Ryan Carr.
So as Kris said, I'm Brian Cara, and I figured for my first lightning talk that I would go over the first security vulnerability that I learned when I was here at Highland. Cross-site scripting is just the ability for a hacker to run malicious code on a vulnerable website. Obviously it's not by design, but it's how it ends up being run is what the problem is. There's 3 types. There's reflected, persistent, and DOM-based cross-site scripting. If this works. Reflected cross-site scripting is just the ability for a hacker to type in text onto a website and get it to run the code while you're actually on the website. So, for example, the hacker could type in information into this contact form. So we'll just do this. And you can't see the submit button, but there's a submit button at the bottom that I can't see either. And it looks fine. It looks like you're just mirroring what's going on the actual screen. Like, right now we're just displaying what the user typed, which doesn't seem like a problem at first, but if we type it in again, but include JavaScript, do I need to use the mic? In general, if we can run at this little script, we can run any script on the actual website, which at first doesn't seem like you're doing much, but you can do a lot more within that script block than what I'm showing here, so that you can take over the site for at least the user that's viewing it currently. Now, it gets even more dangerous when you're letting the user actually get to keep what is on the screen on the screen. So that's when we get to persistent, which is where the data is stored on the server, rather than you type in the script and it's shown for you, this will be shown for every user that hits the screen. And so for this, we'll just use a comment page as an example, where this is a comment, and at first, you'll just not see this at the bottom of the screen. You'll see the comment at the bottom. But what hackers would do is they'd say, oh, well, maybe I can make this bold, and we'll see if it actually does it, which it does. So then you can say script and at first it doesn't seem like it ran, but we can refresh it and it'll run. This is worse because you can do this kind of attack, and everybody that sees a site will be vulnerable to this. So for example, a few months ago, TweetDeck went through a malicious attack where a user put in scripting to what first was thought was just going to be like a heart emoticons displaying, but they opened it up and it would allow the users to retweet that tweet for every user that saw that tweet. So it can get a lot worse than that. There was an eBay one that was recently found out that you can send messages to any user on eBay through another user's account, which has been open for a year and nobody's fixed it. Now that we know that we can actually do these, we got to know how to fix them. And so in ASP.NET, you can fix it by varying how you're going to display the characters. So in HTML, you use HTML encode. If you're using an attribute, you have to do HTML attribute encoding. URLs you are encoding. And then also, so that they would not be able to do query string values with malicious code, you can also do validate request, which is ASP.NET's automatic version of attempting to handle malicious code, but you should always do the encoding regardless of whether or not the API seems to be handling it. And we can see down here at the bottom that that's actually encoded and it's displayed to the user like it should be, rather than allowing it to run. There is a third, lesser known version of cross-site scripting, but it's not very well understood yet. Recently, WordPress was vulnerable to this. It's called DOM-based cross-site scripting, which is where you're editing the document object model through code. And so when you design the site to just display back what the user is typing, you could easily just, at the end of this, run code again, which is just run the same code. And I realized that I ended up talking a lot faster than I was expecting to. But if you have any questions, I'm going to type out my. You can just talk. If you have, does anybody have any questions right now? You would have to encode the output that's being displayed to the user. So, like in ASP.NET, you would use the HTTP utility .html encode. JavaScript has encode URI component, which is made more for URLs, but it's not made for the same exact thing. Did you want me to get more specific?
That's okay.
Okay.
does encoding stop XSS?
Coding stops cross-site scripting because it allows, it encodes the text. So if you were going to be writing this symbol, the greater than symbol, in your actual code, instead it would be, I don't know if anybody can read that. It's the ampersand GT, which is HTML's symbol for its HTML is greater than, what is its longhand version, and that would just stop the code from being run. There's different outputs would be given for each different type of encoding you use. And I could be contacted at, my email address is Brian@arccarrot.us. So if you have any other questions or if you need to talk to me after this, then I can be contacted there. It's just my first name at our last name.us. That's it.
Oh, nice to meet you. All right. Is that coming through? I don't trust myself. So, hands up if you've heard of Microsoft EMET before. All right, good. About half. That's good. EMET stands for Enhanced Mitigation Experience Toolkit. It's in version 5.1 now. Releases come kind of sparingly. The main idea behind it is that, what it does is it forces all these Windows defenses that have been built into Windows over the years, it forces those defenses to be run on applications that haven't been built by Microsoft. It's free. The only caveat is you need .NET 4.0 or above on your machine, which means you need at least XP Service Pack 3 or above, or Vista Service Pack 2 or above, and then 7, of course. So, super simple installation. I'm going to walk you through every single screen. Try and keep up. So, download from the Microsoft site. It's free to download, like I mentioned. Next, next, agree, next, next, next. Here it's going to ask if you want to use the recommended settings or whatever. It doesn't matter. Pick whatever you want. We're going to change it anyway. Next, close, and we're done. So, hope you can keep up with that. But this is a very complex piece of software, I understand, if we have to go through it a few more times. This is what it looks like when you load it up. Not very pretty. You'll got a nice white box down here. It's been redacted because I took these screenshots on my work machine. But normally this will show a list of running processes. So at the top, just go across, we have these import-export buttons at the top. Hopefully you can see these. Those import XML configuration files that will tell EMET how you want the apps to be protected. You have the wizard button, and I swear to God, all the wizard button does is bring this back up. I don't know why it even exists. Apps will take you to the screen that shows you all the apps that you have currently protected by EMET, what mitigations you have running against them. Trust will show what sites you're trying to use for certificate pinning for. That's not covered in this presentation. If you want to look that up, go ahead. It's very important stuff. It really helps mitigate man-in-the-middle attacks. But EMET might only protect against man-in-the-middle attacks run through Internet Explorer. That hasn't really been fully tested, but most people think it only works without you. Most importantly, though, there's pre-configured profiles up here where it says, let's see this one better. Recommended security, quick profile name, recommended security. There's 2 or 3 quick profiles there for you to use. There's way too many styles. I don't know why there are this many styles. It seems kind of silly for a security application, but there are 1,000 different ways you can get this application to look. So it's pretty tricky. Then we have the checkboxes at the top. You can add the events to the Windows event log. You can add a tray icon or not. The early warning system is just that the box will pop up after it's popped and say, do you want to send this information to Microsoft to help improve EMET? I call that program the early warning program. Without any part of it, that's that checkbox. All it is. So, what's a quick way to set this thing up? This kind of seems like a lot. What if I'm just like installing this on my grandma's machine? I don't want to spend like an hour putting all this stuff together. What do I do? All you do is change this checkbox here to maximum security settings, and it will set a ton of stuff for you. You don't have to change anything. And you know what? I do it on my machine at home. I do it anytime I install it. It's just the easy way to do it. Why not? Doesn't cause any problems. From there, what you're going to want to do is hit the import button on the left, and it'll bring up this. It'll say, do you want to import these XML files? These come with EMET. These are recommended software from Microsoft, and they're recommended mitigations, because certain mitigations will cause problems with certain pieces of software. They've worked out which ones are which, and they've done all that for you. Go ahead and just import all three of these. Import one, hit open, do it for the next two. Even the Search Trust one, and this is what you'll see afterwards. This is what happens when you hit this apps button over here. You'll get this screen. Over here is a list of all of the applications that were in those XML files. All of these checkboxes are the lists of mitigations that EMET will apply. You can see some of them are checked for everything, some of them have some things unchecked because they've identified performance issues or they just don't work. Here's all that's in the certificate pinning. It's kind of silly, it's just like Facebook and Yahoo, some Microsoft sites. But hey, it's better than nothing. So if you want to play with that, you're more than welcome to add stuff to it. I highly recommend you do. Of course, you can do the same thing with apps. At the top, there's just a big plus button, hit add app. Literally, you just have to navigate to the application, not even the root application. You can just hit a shortcut, and it'll add it. And you can say what mitigations you want there. Now, if your piece of software stops working, there's a decent chance because of that, you want to start taking those mitigations off and see what's doing it. After you've done all that, you'll get these two notifications that say you need to restart your computer to make some changes, and down here, restart some applications in order to get the applications to be running in it. After you do that, this is what it'll look like. When you have an application that's successfully running in it, you'll get a little green dot next to the application. So here you have Firefox, and over there there's a green dot that says running in it. This reporting tool is garbage. It doesn't work at all. I think there's like 4 or 5 apps that will correctly report whether or not they're running EMET. So how do you make sure that the application you want to be running EMET is if it's not showing up here? Super simple, actually. Go ahead and download Process Explorer from SysInternals, also free. Pull up the one you're concerned about. Here I have Firefox isolated, and hit the DLL pane. It shows you all the DLLs that are running under that process. And underneath there'll be an EMET DLL, maybe 2, depending on the application. But here we have the EMET shim. Just take a look for that, and that lets you know that EMET's running on it. That's how EMET works. It injects DLLs into the process to get these mitigations going. So again, if you have an application that's in your application pane here, all this stuff is set up, but it's not showing up as reported here, go ahead and double check with Process Explorer, make sure that it is actually not working or is, and just not the reporting tool that's causing problems. If you work in software, you should be testing your product with this. This is our product. This is the Unity client for OnBase here that I've added. Just like I said, just hit add application, navigate to the application, go ahead and start checking boxes. So, I'm not following my own advice. We haven't really been testing this as much as we should have. So I had to start running some tests today. Major performance problems with all these on. So what you do is you just start checking them off one at a time. For instance, this EAF plus, one of them, if you have that on in Firefox, when you start Firefox for the first time, it'll take about 3 minutes to open. But if you uncheck that, it works fine. So just watch out for things like that. However, the protections this provides are worth the time to say, hey, we tested this in-house, we made sure all of our functionality works with this set of mitigations in EMET. And you should be recommending to your customers that they use it with your application, because why not? So, what are these mitigations? This is going to get a little heavy, but we're going to go through kind of quickly. So, first one is SE Hop. This one you'll hear talked about a lot. This protects against a common Stack Overflow exploit that's used in the wild. It was part of Windows since Vista SP1. Basically what happens is that normally attackers try to control certain exception records that are called in the event of an overflow. What EMET does is it verifies that exception chain hasn't been tampered with before it starts calling these things. So if an attacker has placed their own malicious code in somewhere that's going to be called in the exception stack, the application will terminate before it gets to that point. So EMET kind of injecting itself in the process there. Data execution prevention, DEP as it's called. So this has been around since XP actually. Again, Microsoft, non-Microsoft products generally don't run it unless they put the .NET frameworks in to actually use it. So EMET does it for you. It protects against attackers calling into shellcode at a particular location in memory that they control. Normally, these locations in memory are marked executable by the OS. They'll say anything that's here can be run. What DEP does is it takes these very common places that malicious code is put in memory and marks them non-executable. So even if this malicious code is called, it's marked as non-executable. It's sort of like cross-site scripting, where it's just harmless text now that's being called. So it just prevents the application from running. Heaps reallocations. When an exploit runs, they generally have to guess where their shellcode is in memory. So what they do to increase that success rate is they do what's called heap spraying. They just put their shellcode all over the place in memory, hoping that they'll land on it by accident. What EMET does is it, again, takes some of these most commonly used address spaces and just takes control of them. It says EMET's running here, so that these exploits will fail. You have to understand, these exploits are not very smart. They're kind of built for one purpose and one purpose only. They're not meant to adapt along the way. So the attack is launched, fails, it fails. It doesn't have any sort of adaptive thing in general. This feature needs constantly updated along with EMET because these common places are always changing. The way exploits are using these addresses is always changing, so EMET has to keep up with that. Mandatory address space layout randomization, commonly known as ASLR, protects against what's called ROP attacks. ROP is random return-oriented programming, and what that does is attempts to bypass DEP. So you have DEP here, which is protecting against shellcode calling in memory. You have attackers who are not only trying to bypass whatever exploit causes them to get to the point where DEP is stopping them, but you also have them trying to bypass DEP, which is what ASLR is. It's very deep very quickly. It's kind of a cat and mouse game that Microsoft and exploit does in the plane. Basically what it does is it randomizes memory addresses where certain modules get loaded. So it stops attackers from taking advantage of knowing where a particular module is always in memory, so they can just call that address. Then they can just call that address, they'll know what's there, and then they can execute against it. With ASLR on, that address will not be accurate. This has been native in Windows 8 and 8.1, and will be going forward. So you don't even need EMET for ASLR to be working on non-Microsoft applications if you're running Windows 8. Last one we're going to talk about is EAF, or Export Address Table Access Filtering. To be useful, generally exploits will call Windows APIs in order to do something once they've made their way onto the system. But it has to find where in memory that API is loaded. So to figure this out, what they do is they iterate through a table called the Export Address Table, which tells them where these things are loaded in memory. All EAF does is limit the access to that table. They can't read the table, then they can't look up where these APIs are loaded in memory. They have to guess at it, or they have to just make random attacks, and that's where the other protections come into play. This blocks a significant number of current exploits. This is kind of a trend today with exploit, is using this table. This has been quite a pain to that. So I bet a lot of you have heard, if you've heard of EMET, that EMET can be bypassed. Every conference has some sort of guy talking about EMET bypass techniques. You'll hear it on Twitter every week. Hey, I found a new way to bypass the new version of EMET. Every time a new version of EMET comes out, a week later this guy, I have a new bypass attack. I particularly love this tweet by this guy I don't even follow, but he's fantastic. It says, not running EMET because it can be bypassed by researchers doing next level shit is like not wearing a seatbelt because a sniper can get you. I tend to agree with that. EMET is just a tool. Sure, it can be bypassed. But you know what? It's a layer. Just like your antivirus has all kinds of weaknesses too. No reason not to use it though. It's simple to use, it's free, it's easy. Toss it on, worries are taken care of. That's all I have. This is me on Twitter, @TrollUp, and email Kris@TrollUp.net. If you have any questions, I'm more than happy to answer. Thanks.
Kris,
Sir.
I'm assuming those XML files that come with EMET are also updated when EMET gets a new version, so you get your lists.
Yeah, every major version of EMET comes with new. Unfortunately, that's the big weakness of EMET right now, is it doesn't have like an update feature. You have to go to the website, get the new one, and download and install it. When you do that, I recommend pulling those XML files again. All right. Next up is Marius, getting started with the new GNS3. Thanks.
Everybody. I'm going to talk to you briefly today about GNS3. It stands for Graphical Network Simulator. And this is the new version of GNS3. They used to have like a sort of a beta version that was stable enough to use, but pretty limited in functionality until they actually came up with a Kickstarter program. Got a ton of money because people really support GNS3. It's a great tool. Now they have like a truly official website and a bona fide release, and they even offer services to companies and things like that. So GNS3, we're going to talk about what it is and how exactly to use it. Starting with what it is, it's just a software-based network emulator. It allows you to simulate routers, switches, even hosts, to craft your own virtual network right from your machine. By the way, every time you see these red brackets, that means the slide has information specifically pertinent to GNS3, as opposed to just general stuff I'm talking about. It does have the ability to emulate actual vendor devices, so Cisco, Juniper, they've been adding support for a ton of other ones, I think Dell and HP even. So traditionally, it's been used for people to study for network certifications, to configure and secure network infrastructures and things like that, for proof of concepts, for your company wants to purchase this vendor's firewall. You can grab the software version of that firewall, plug it into GNS3, see how exactly it works, and play with it in a virtualized environment. So that's the traditional use of GNS3. And this is what it looks like now. So this is the new version. I downloaded it just the other day. And as you can see, I have a couple of dummy hosts in there with a switch. It does support like a very basic switch functionality. I'll talk about it later as well. But my overall point today will be that yes, GNS3 can be used to study for your network certs and things like that, but it also can really complement really well your home lab for security testing. but I'm not into networking, get over it. Networking is a great foundation. It allows you to make all these different connections, meet people, get jobs, right? Not just networking like we're doing now, but actually networking concepts. I'm a networking guy. I came up in networking, and I was always interested in security. So when I started moving into software security, at first I thought, these concepts are totally unrelated. You can't really relate XSS to packets and things like that. And truth is, at the very technical level, yeah, maybe not. But it's part of a sort of pyramid, I guess. If you have the understanding from network security concepts, you can really outline and understand the entire process of an attack. And the biggest argument against, I guess, learning network concepts, specifically security related, is that the perimeter, so to speak, no longer exists. And that's all and good, but then doesn't that become also an argument for learning about security concepts related to networking? Because if the perimeter doesn't exist, what can I do to protect my network now? And those things still apply. You can still do a lot of hardening in your internal network, even if the perimeter doesn't exist because of application flaws. So this will, learning at least a little bit about networking, you don't have to go way too deep into it, will allow you to understand things like DNS poisoning, ARP poisoning, ARP DNS exfiltration, which is a very modern, I guess, way of actually stealing data out from a target network. Things like network segregation, VLAN hopping, and at the very, very, very least, if you understand these things, you'll be able to protect your home network. And at the very most, you actually have the ability to control the infrastructure at your job, or if not control, at least influence some decisions that can lead to greater protection of your infrastructure. There's I didn't include it in my talk, but I just thought of it now. There's a talk by Moobix, I think, you guys can correct me, about pen testing ghost stories. And he talks about what kinds of things in his pen tests actually gave him a lot of trouble. And lots of those things are network related. It's segregating the network. It's not having default administrative VLANs. It's segregating your VLANs properly, and things like that. So learning about all this gives you that great foundation to understand how to add those extra layers that are still relevant because there's no perimeter. And networking plus GNS3 will supercharge your current pen testing lab, because you can then grab all your VMs that you're using, link them together in a completely isolated network. It's also safer that way. You don't have to open the VMs to be like associated with your actual hardware interface or anything like that. And I'll show you how that's done. So even if you don't want to learn Cisco and Juniper devices and things like that, you don't have to use GNS that way. You can just use GNS for its basic features because it integrates with VirtualBox, which means you can build VMs that are running software routers and software firewalls and use those instead of GNS's vendor-specific setup. Now, if you're interested in learning Cisco and Juniper and so forth, I do highly recommend that you look into it. Technically, you need licenses and stuff to get the software to be emulated, but the internet is the internet, right? So you can craft VMs, grab a bare metal, or not bare metal, bare bones Linux VM, just to use IP tables, for example. That would be enough. Grab pfSense, which is an open source router and firewall distribution. Grab Untitled, which is sort of an app-based next-gen firewall, which is free for its basic services and some basic apps, more than enough to learn. Anything that you can put into a VM, any favorite routing platform that you might have, will fit into GNS3 because of this VirtualBox integration. Basic switches are built in. You don't have to get anything that does switching, though it does. Some of the vendor-specific features do allow for advanced switching emulation. And again, you can create that way a completely isolated network that connects all of your vulnerable VMs, all of your attack VMs to vulnerable VMs. You can put the firewalls in between, so you can try things like web application firewall bypassing attacks, and that's actually something that connects XSS to the infrastructure, because you have your web application firewall sitting there in between, and you're trying actually software attacks through the firewall all the way to your vulnerable VM. Also, probably my favorite feature, it tells Wireshark to start a packet capture on a single link. So you can right-click a single link in your topology, and GNS will launch Wireshark and start an active live capture of only that link. That means you don't have to deal with all the noise of your actual network interface or anything like that. Only what goes through that specific link will come up on Wireshark, and you can examine exactly what's happening. So that was sort of what GNS3 is and what you can do with it. Now let's check out how to do things. Download is free. It does require an account since they launched the new version, because they have like a community feature and stuff. Lots of resources in the community, actually. You'll not install any crap without asking, at least as soon as of yesterday. So when you grab it, feel free to install everything. The only sort of crap, I guess, is the SolarWinds response time viewer, which is also free, but then you have to also register with SolarWinds, and I don't want to go through the trouble, so I just skip it. But I do recommend that you at least install, obviously, GNS3, Wireshark, WinPCAP if you're running it in Windows. It's what allows GNS3 to interface with Wireshark for the packet capture. And VPCS, which is this virtual PC simulator, which allows you to drop those dummy hosts into GNS3 and have very basic functionality just to check out if your connections are working properly, and I'll show you a bit more about those as well. Then grab VirtualBox from virtualbox.org. That one is also free and does not require any registration. And before going on to GNS3, start making your VMs first. And there's only one requirement. So after you grab your ISO from pfSense or whatever, or you build your Linux VM, just go into the network tab. This is the settings for the specific VM. So in your VM, you can go right-click, Settings. You see this window. And then you see the network option right here, and you can have up to 4 adapters. So enable as many as you need for your lab, and then set every single one of them to not attached. This will allow GNS3 to attach itself to those interfaces as you've configured them. And this is the only requirement. After you use them through GNS3, this will change to be attached to like a generic adapter, because GNS3 is doing its thing. So don't change it from that. Otherwise, you have to like reconfigure it inside of GNS3 again. But in the beginning, set it to not attached, and you're good to go. So finally, open GNS3. In Windows, it does require admin privileges. By the way, it also runs on Linux and Mac. On Linux, for some features, it may need root execution as well. So in your preferences, you'll see there's a VirtualBox branch over there. Just make sure it should already be set. Just make sure it's pointing to the correct location of vboxmanage.exe. That's what it uses to integrate with VirtualBox. And then select VirtualBox VMs right underneath VirtualBox, and hit New down here. This window will open, and right then and there, it will show you, will populate the dropdown with every single VM that you already have created in VirtualBox. That's why you create them there first, so you can see them here afterwards. Select the one you want to add into GNS3, hit finish, and that's it. So back at the main GNS3 screen, you will see this. The first red box over here gives you switches, including the sort of basic built-in functionality switches, which is what I have here. The one with the little monitor is all of your end devices, so all of your hosts. Because I added my pfSense VM, there's my pfSense VM there, and this is virtual PC. So I dragged virtual PC into over here. It said PC1. If I dragged another one, it would say PC2. And then you can go ahead and link them together using this little button over here. And the interfaces that will show up depend on how many interfaces you set on those network tabs in VirtualBox. If you set 2 of them, you'll have the option to attach those 2 interfaces to different places. And then go ahead and right-click all of your hosts and hit Start. And that will start your VMs in the actual little VM window. There's also an option to start them in headless mode. Nothing will show up, they'll just power up. If you hit Console for the virtual PC, you'll see different options like get your IP through DHCP, ping somebody, show me your ARP cache, very basic and generic networking things that allow you to at least troubleshoot your connectivity. Heed this warning. Stop your, when you're done with everything and you're shutting down, stop your VirtualBox VMs from the VirtualBox interface itself, not from GNS3, because if you stop them from GNS3, you'll just shut it off, and it's not a safe power down. So go into your VirtualBox manager, power them down safely, and then come here and hit the stop. Finally, you may end up with something like this. I have a series of hosts. I have my colleague VM in there, going across a pfSense, which I've configured to be accessed through the internal network. So this is my vulnerable VM accessing the config for my pfSense through the switch. Here I've started a packet capture specifically only on this link. You can see some of the pings I've made, and only what goes exactly through here will be captured, nothing else. You can start multiple captures at the same time, so you can see what's going on everywhere. This is an example of the console for the virtual PC. I just did DHCP and I acquired a IP address from my pfSense box, and then I sent some pings across to the vulnerable VM, and those are the ICMPs that you see in Wireshark. And from there you can start crafting your own lab. You don't have to attach any of the virtual machines to your actual networking interface, to your actual hardware, because they're all virtual interfaces that GNS uses. You don't even have to do NAT or anything like that. And you can have your own separate, segregated configuration of things like pfSense or Untitled or OpenSense. And that's it for GNS3. Any questions? Anything that in particular you can think of that you'd like to use GNS3 for, but not sure how? Yes?
Do you know if there's any integrations with VMware, or is it just virtual?
Any integration with VMware? Not that I know. I don't know if they've planned anything for VMware. The reason they integrated VirtualBox to begin with is just because it's open source and available. And so they've integrated with VirtualBox since the previous version, and they just carried over to the new version as well. So they don't do VMware. I don't know if they have plans of going that way as well. Anything else? All right, here's some resources for you. That's my website. If you go to the homepage of my website, there's also my contact information there. So if you go there, /projects/gns3.html, I've got some suggested routing platforms for you, like pfSense and OpenSense and Untangled. There's a link for a bunch of resources presented by the GNS3 community. So they even have a list of appliances that were prepackaged for use with GNS 3. There's a link to a talk at Derby, besides Cleveland, just last year, about pen testing layers 2 and 3, and it'll tell you all about DNS attacks and VLAN attacks and VLAN hopping and all those fun things you can try out yourself. Cool, thanks very much for listening.
All right. One more round of applause for our first half speakers. Good stuff. We're about halfway through the talk, so we're going to take about a 10-minute break here. There's still plenty of pizza left and soda, so go ahead and take that off our hands, and we'll get started back up here in a little bit. Thanks.
I don't know what's happening. Accessible to PC doesn't define only mobile. Huh. No idea why. I tried to see the certificate on Firefox. I would have phoned it. It is from start to sell, so it's not like it's not like a managed CA. Yeah. So Gmails. Nice. Yeah, I can drop the resolution.
Oh, never mind. There it
Sorry.
Consider email for a week.
Oh, when you lock
You know what, I locked it,
When you log back in, whatever, screw it. Over this projector, man.
Dude, this whole room is falling apart.
Alright.
No, no battery in this one either.
Oh, no battery there either? Was I talking the whole time or not?
Oh, there you go. We're good. So unfortunately on the way over here, I lost my virtual box. So I'm not going to have a demo for you today. I talked to Kris and I'm going to record it when I get home. I have to change my resolution. I'm going to record it when I get home and I'll send it out to the CleveSec Twitter and we'll send it out. Do you want me to change my resolution?
Yeah, I don't know if we're missing something on the corner of the screen.
On the left.
Yeah, that doesn't look so bad. We will.
I had to drop my resolution to 1024 by 768. I don't know what's original.
Yeah, I think my presentation came out only 4x3 for the solution.
These two were switched.
Oh, yeah?
Yeah. There you go.
Yeah, perfect.
Okay.
Everything was 61.
So look for the actual demo later, either tonight or tomorrow. You could you can find me at Woolly 6-Bear. Like we were just talking about. I retweet a lot of security stuff through there, some sports, mainly all retweets really of the security. So two quick things. I grew up in the system admin world, hardware, software, that type of stuff. I just stumbled upon being in that world Exchange. I really wasn't an admin of Exchange. I really just came up in conversation one day. I looked at Hub Transport and I just saw what it could do, and I thought, what else can I do with it from a security standpoint? And so that's basically where this talk came from, is all the different little things that I found I could do with it. I'm not trying to sell this talk as being an end-all for phishing. It's just another little tool you can add to the toolbox. Phishing is not about technology. Too many different, the bad guys are just, they know their way around. They can get in. Our leaders, our C-level executives, they all want emails to come through, so they're asking you to turn down your spam filters. Phishing is all about information, is all about education. So this is just what I'm going to show you here is basically just giving you a tool to give to your users so that they can make an informed decision about whether this email they're receiving is phishing or not. Here's a little phishing test I ran probably about almost a year ago now. Well, actually not a year ago, it was only 4 months ago. I sent this out at exactly 3:35 p.m. and at 3:35 and 19 seconds I received my first hit. And at 3:35 and 40 seconds I received my first password. So phishing is obviously a problem at my company at least, and probably at your company as well. It's just everywhere. It's the #1 attack method. I would show you a demo, but it looks like this right now. So hypothetically speaking, if I were to click on here, the little menu would pop out from below there, and I can show you what that looks like though. I figure I go on Google and I find it somewhere in here. So under your management console, you have Hub Transport. You have all these transport rules. The transport rules is basically any email that comes through your Exchange server, coming and going, will pass through this Hub Transport rules. And so what you can do is set up various rules in here. I'll show you one of them. So one of the rules that we have set up, this is a disaster. One of the rules I have set up basically is to look at any emails that come in externally. So all our internal emails that we send to each other will not get picked up by this rule. It's just any email that comes in from the outside. What we do is we set that in the subject line. We set that in brackets. We put external. So we prepend the subject line with that. This way, it gives the user, if anybody tries to, mimic like our IT administrator, our HR, whatever the case may be, if it's coming with that external in the subject line, it just gives them that piece of information that, hey, this is probably not coming from somebody here within the company. I wish I could show it to you, but basically there's different steps of rules. One of the rules you want to add to the end of that, though, is to not add external on if it's already there. Otherwise, if you get into an email chain with people outside your company, it's just going to keep prepending the external onto the front of it. The one other option, or one other demo I wanted to show you was basically, the other attack method is a lot of the times they'll set up a fake URL. So for Anthem, for example, they may do Anthem with 2 N's, whatever the case may be, and they try to send you emails pretending to be from Anthem with the vulnerability, not the vulnerability, but the attack method in there somehow. What you can do is, whoever your company uses for your HR, different functions, for all your different vendors that you have, you can set up a rule that says if it comes from specifically Anthem.com, ADP.com, whatever the case may be, you can prepend the subject line with ADP, with Anthem, with brackets. So you can say, if I'm looking for a specific email address, support@anthem.com, or support at, whatever the case, wherever your emails come from those vendors, you can set up rules in here that say, if if it comes from that specific email address or that specific domain that we use Anthem for our for our benefits, we're going to prepend the subject line with in brackets Anthem. And then anytime we send that email out, we may also set up a rule that says if it has the bracket Anthem bracket external, we're going to remove it so that when it gets sent out, the people on the outside don't know that we're doing this. Just cleans it up, makes it look nicer, especially if the emails exchanges, you're trying to keep it professional. So those are two different methods that I use. Again, let's see if I can find a good little picture here. Well, I had one. But basically, you just open up your Exchange Management Console. On the left here under, I think it's just under Organizational Configuration, you have Hub Transport. And then on the right here, you'll have New Rules. And then just like Basic Wizard, you can go through and you can set it all up. My suggestion is also at the end of the rule, you can add an exception that if it's already there, whatever you're setting up, don't add another one just so you don't get that long line. But that's my contact information. I threw it up there on the end just because whenever I get this fixed, whatever is wrong with here, I'll put a little video together and I'll send it out, demoing everything I just talked about. So, any questions? All right, thank you.
Next, we're going to have a talk that Mr. Mauriello will tell you you don't need, but we're going to do it anyway. 5 basic adjustments that will help you secure your work.
One of the reasons that Oracle security can be so tricky, or not necessarily tricky, but can fall through the cracks, is because there are some components that don't clearly fall into a layer that someone is managing. For web apps, there's a lot of web app security developers who are interested in making sure that the data is getting to the database in a safe way. And many of the DBAs will make sure that the data is encrypted once it's already in the database. But for the most part, they're often concerned with making sure that the structures and the performance are good in the database rather than actual security. So, that's probably another area of focus. There's also a lot of features of the database that kind of fall between groups. For example, if you're talking about the physical structures of a file server, the web app developer and the DBA may know all the ins and outs of the database, but that might be a separate person who's managing that, and they may not object to the fact that this person is following all the best practices for Oracle database. So anyway, moving on from that, Oracle is also known for saying that it is secure by default. They do a fairly good job of following some good best practices, but I'm going to talk about 5 things that are not secure by default and that would need to be secured offhand. You can also Google some pretty funny reactions to Oracle's claim about being secure by default, as that challenge was certainly accepted. So, number 1 is do not perform a full installation. If you go into the Oracle installation software, one of the top choices that you can just install all of the components. One feature of security, which I'm sure you all know, is to reduce the attack surface. The more components you have, the greater your surface is, and the more likely you are to be attacked because of that. It also can lead to problems with administration. For example, if you install a web UI for accessing the database and no one is monitoring that web UI and making sure that it's properly secured, there's another in that someone can have. A lot of those components are probably things that you're not going to use on a day-to-day basis, so if you're not going to use it, don't install it. Second thing that can be done is to lock down OS access. As I mentioned a little while ago, the Oracle databases on a file system. This is notorious for being one of the areas in which Oracle and any other database can be a little bit vulnerable because, again, the DBA often isn't the person who manages the file system. The file system manager may not know the specifics of Oracle, and so, they need to work together to make sure this is locked down. You can follow all the best practices for security access through the web app if your Oracle's database is accessed through the web, and for encryption at the database level. But if the file system is vulnerable, so is the database. So, this is basically a statement of the fact that you should be giving the least privileges necessary because that's the most secure. Third thing that can be done is to lock down the Oracle listener access. For anyone who hasn't used Oracle, what the listener is used for is the incoming request to the database. It's what receives some of the TNS calls, if you're familiar with that. So there's a vulnerability in the listener program that will allow anyone to dynamically change the location of output files when logging or tracing is enabled. Obviously, this could be a problem because you could be logging and tracing things that you do not want everyone to see. Also, if the location is set to an existing file, a user can set the location of the output file there and overwrite anything if the Oracle user has access there. Another nice feature of the listener is that there is a parameter called admin restrictions listener. By default, this is set to off. In a security environment, it should be set to on to avoid these issues. It's an obvious usability issue because I don't think anyone's going to look at admin restrictions listener and understand exactly what it is that feature does. So that's something that gets frequently overlooked, and because of the example we talked about where files can be written to any location, if that's not done and things can be changed, parameters for the session can be changed dynamically. If that's not done, that can be a security vulnerability. So that needs to be turned on. Fourth thing that can be done to make sure that Oracle is more secure is to not grant any unnecessary privileges. Again, this is another least privilege component. So many people assume that if there's a default role in Oracle, it's going to be safe and you can grant it to anyone that Oracle documentation suggests. Here's an example of one that's not like that. There's a role called select catalog role that's usually used to let users see structural information like the table definitions, the store procedure definitions, the view definitions. All this metadata, it's pretty harmless. Another thing that's considered metadata is a lot of the user properties. So you can see the users and their roles, and you can see the stored encrypted password, which can be an issue. If the passwords are not strong, it's going to be pretty easy to look at different encrypted values and see, hey, these look pretty similar. Encrypting the passwords is going to make sure that a default dictionary attack may not be as successful. But if a weak salt is being used and everyone has the ability to see these weakly salted passwords, it's really not going to be safe anymore. So do not grant unnecessary privileges. If you have a default role, such as that role, make sure that you know what's in it and don't just blindly trust that Oracle wouldn't have given you anything that you're not supposed to have. So finally, the last thing I want to mention is using a strong salt for your passwords. As I mentioned a bit before, the salt is what's used to show the encrypted or hashed password value. If a weak salt is being used, the encrypted values are going to look pretty similar, and anyone with just a little knowledge of cryptography is going to be able to start taking your hashed passwords, comparing them to one another, and figuring out pretty quickly which characters correlate to which English characters. So those are just 5 quick things that you can do in an Oracle database to make it more secure.
Alright, very practical stuff. Next up, we have Adventures in Reverse Engineering. We're going to learn some do's and don'ts. We're told most of don'ts.
No. my adventures in learning reverse engineering. This was the title given to me by CleveSec, but I thought it was appropriate. I'm Eric Faehnrich. There's my Twitter if you want to find me. I've been meaning to learn about reverse engineering for some time now, but the lightning talks was a good opportunity to force myself to actually do it. I've never done reverse engineering. In fact, I've never done any InfoSec stuff at all. This is all new. I don't know about the Oracle and Exchange stuff, no idea. But I do have some good background based off of, my background is in computer engineering, so I can get into the low-level stuff easy enough. And I've been a developer professionally for 10 years, altogether about 20 writing software. So I have some good stuff to go off of. Now, two things about this, like I said, brand new. I don't know what I'm talking about. That's something everyone wants to hear a presenter say. The other thing, this little reverse engineering exercise was a failure for me. So I'm setting the bar low for this. Now, there's lots of resources out there for learning reverse engineering, like crack me's and simple reverse me's. I learned that's what they're called. But I had something specific in mind that I wanted to try my first foray into reverse engineering on. The game Quake came out on these free shareware CDs. You can install Quake with just the first few levels, and then if you wanted the full game, you had to use this CD to generate a challenge key, and then give it to someone over the phone, along with payment for the game, and you get the full game of Quake. And you used just this CD. This was pre-Steam days. And so the entire game is already on the CD that you got for free. Not only that, but also I think their entire library, Doom, Hex, and all that, it was all right there. It was just protected by a key that you had to give them, they gave you the unlock key. So that, of course, meant that someone developed a cracking program called QCrack to crack it. This is the actual floppy I had the game, or the QCrack on, someone gave me way back when. So you just run this, and input the challenge, and it spits out the key, and you got all the whole library of games for free. So I figured a full GUI installer might be hard to figure out how that key generation works. I just wanted to find out how it generates the key, and so I just wanted to find out how it generates the key and generates the unlock key and verifies that it matches. So I figured the GUI installer would be pretty difficult. I'm not going to that. So console application, a lot simpler. I'll try to reverse that. Simple, right? No. So first step was figuring out how Windows binaries work. If you just build a little hello world, run it, Windows, it does that. But if you run it in DOS, you'll get something different. So there's a difference. And it turns out, inside Windows executables, they all can have their own little DOS program inside of it. When you run this in Windows, this is called the DOS header. Starts with MZ for the guy that came up with the DOS file format. When you run it in Windows, it just looks for the offset past this little DOS program, and then looks for the PE header. That's the start of the actual Windows executable, and then just finds that, and then it goes. But they, I guess, wanted it backwards compatible to throw out this little warning that said that your operating system is obsolete. Maybe upgrade. So this is an actual DOS executable. It has the offset, says go here. Here's where the code starts, and this is the entire program right here. and then of course the little bit of text data. So that's pretty small. This is the whole program in the header compared to, and this was just that hello world for Windows. It just printed out hello world, and it turned out the entire program was 194 kilobytes compared to just megabytes. So that's progress. So we can actually, even just start looking at just that small program inside of the DOS header. So you push the code segment onto the stack and you pop it back off into the data segment because your code and data are both in the same segment. We're moving OE into the 16-bit D register. That E is where this string is stored, starting right here. So we're just telling it where that string is. And then move 09 into the high byte of the 16-bit A register, because when we do that and call int21, that tells it just print that string out. Print out the string, whatever D is pointing at. And then after that, 4C for terminate the program with 01 exit code, and just call that. So there's just one example of that. The QCrack program is a DOS executable only. It does not have that PE header because it's only a DOS header, because it's just a DOS program. But it's same structure. You have the header pointing to where the data starts, instruction pointer says where to start executing. It even looks the same. OE1F for that, OE1F for this. All right, so I have the DOS executable. Can I run that in Windows? No. Turns out Windows NT is not DOS anymore. You need Windows 95 for that. So in order to actually get this to run, you need something like a DOS emulator. I use DOSBox. It's great. It's better than starting a virtual machine and trying to install DOS on that. And so at this point, I should be able to run executable, right? No. Load that up. Load error. No DPMI. What is that? Turns out that's DOS protected mode interface. So with DOS 3.0, they said, hey, these processors we're getting have a lot of really neat features like protected mode and virtual memory. Let's let DOS programs use that. So I had to find out what a DPMI is. Luckily, I found a clue really early in the executable here, CWS DPMI. So it loads something called that. So once I found that, I suppose that was supposed to be it. I put it in the same directory, and lo and behold, I can finally run QCrack on a DOS emulator. So I can run it, but if I'm reversing it, I want to be able to debug it. I can't exactly load Visual Studios into DOSBox. So that means I need to find a DOS debug program, and it turns out that there is something called just that debug. So I then find that, and lo and behold, I can finally step through code. I can look at the registers. I can step through trace, and I'm off from there. First time doing trying to reverse engineer a binary. What you think it is, it's kind of tedious, just stepping through. But one thing I noticed what it's like is also just like debugging when you're just writing software and you're debugging. Of course, the obvious difference is when you're debugging, you have the source right there. Reversing, no source, just the binary. And with debugging, even though you have the source, when you have to debug something that's wrong, that means that it's not doing what you wanted it to, because you have an expectation of what it should be doing, and it's not doing that. With reverse engineering, you don't know what it's doing, so there's no expectation. I don't know if that's good or bad. But in both cases, you're stepping through and you're building a mental model of what it's actually doing. With debugging, you have to build that mental model to find out where it doesn't match up with your expectation. With reversing, you're just building that mental model because you are trying to figure out what it's doing. One interesting thing I found was this loop. It was a loop to parse the path environment variable, and the first thing you see in this loop is test instruction. Test just ands the two operands together. It doesn't store the result. You just have the flags to check. And then right after that is a compare. So we're testing and then overriding our flags. I was like, okay, it's a completely pointless instruction. And then you go down and you say, okay, jump back up to the top of the loop for 5. Well, wait a minute. Here's 4F, 5.2. That 5.0 is in the middle of this instruction. I thought this was kind of weird. This is actually something I've seen before, even though I say I haven't done reverse engineering. I've read about stuff. Jumping into the middle of some other instruction, I've actually seen as an anti-reversing technique. And so I thought, is someone really trying to protect this from being reverse engineered? Well, I just kept on stepping through, and it turned out when you actually step into the middle of that, that instruction is a valid instruction that they actually use. This was just a clever assembly technique. On the first way through the loop, this does nothing, but any subsequent time around the loop, it performs an instruction that they needed. So I thought that was pretty neat. So at this point, yeah, I was stepping into that DPMI code, and I was crashing DOSBox. I wasn't just crashing debug running QCrack. I was crashing DOSBox. Everything I tried to look up said, yeah, DOSBox isn't meant to do that. DOSBox it's meant to run games. This is why I originally had DOSBox. This is the game Dune 2, D-U-N-E, from the Frank Herbert to Dune series, real-time strategy game. So this was what my tool was meant to do. This is what my environment was for, was playing these. So that's where I've been stuck at. Remember I said it was a failure, low bar here. And yeah, I'm stuck here. I learned a lot. I learned a lot. First time looking at x86 assembly code. But from here, I can keep banging my head against this. I actually do think that that's my best course of action right now, is just keep looking at DOSBox. Something else I can do is try to bypass the limitations of DOSBox and actually put this on a virtual machine with something like FreeDOS installed. Maybe that'll get around those limitations. I don't know. Or I can try to do the thing I was trying to avoid in the first place and reverse the actual Quake program. But yeah, it turns out that is a Windows 95 program. So again, I need a virtual machine with Windows 95 running on it, and I don't know where to get that. Something else I thought of, actually generating the key pairs, not reversing any binaries, but trying to see if I can figure out how the keys work just with the pairs of keys. They didn't seem like extremely long, so possibly not difficult. But again, I need to actually run the original program with his Windows 95. So that's it. If anyone has any tips about where I could go with this, they'd be appreciated. But thanks.
All right. And for our last talk of the night, we are going to take a look at ArcSight. Mr. Kris Hamilton.
it's situated. Does anyone work with SIM at work? No? Wow, this is going to be super boring. I really apologize. If I didn't hear, this okay? Cool. Okay. So I work with ArcSight. I work at KeyBank here in Cleveland. If you guys bank with them, I'm really sorry. I'm a security guy. No, I'm kidding. No, they have great security. Really, they do. So ArcSight is a SIM, Security Information Event Manager. Sometimes people would say it's a monitoring platform. So what does the SIM do for you? SIM provides a holistic view of all your organization's logs. So what does that do and how is it useful? Well, if you're going to look at everything in your entire organization, it helps to be able to see everything. If I have to look at my firewall logs, I have to look at my proxy logs, it helps to be able to compare those two together. If I have to look at my source fire logs, or IDS logs, it helps to also be able to look at my SQL logs at the same time. So that's what a SIM is going to do for you. So this is the ArcSight correlation platform here. So a lot of people will come to us and say, well, what can I put into a SIM? What can I do? And I have to tell them, I can literally put anything into the SIM. It's just a flex connector. So as long as you write something that spits out logs, we can turn around and put that into ArcSight. But then the next question is why do I care if it's in ArcSight? So we have to come up with use cases in order to actually use that information. So if you tell me that you want something, I ask you the next question is, what do you want to see come from it? So ArcSight is a HP system now. It actually started as a startup, and it got purchased by HP as their SIM platform. So there's other SIM platforms you guys may use or may have heard, such as QRadar, Nitro, Tripwire, OSIM, which is free. If you guys haven't had a chance to play with that yet, it's by Alien Vault. So it's free. You guys can set it up on your own. It takes about half an hour to get it set up. And you can start feeding things straight into it. It's really good exercise at home if you haven't done it. I recommend it. When people ask me where I get started in security, I would say start with OSIM. It's a great correlation engine. So ArcSight has topology. So we talked about this right here, and this is the things that's going to feed into it, like your host-based IDS. If you have an antivirus, something like that, you can feed in. If you have an IDS, such as SourceFire, it can feed in. Anything like that can feed. But when you're also looking at things like this, you have to look at your topology as well. So ArcSight has a couple ways of dividing your topology. You can divide it by zones, which is just IPs alone. So if you guys are going to break your topology apart by DMZ, ASC, whatever you want to break it apart, like even if you want to go as far as to say my VLANs, you can do that by zones. But what if you're a MSSP or you have multiple private IPs within your network, which can happen, especially if you're a company that's acquiring a lot. So you can break it apart by network. So you can have the same IP range in the same in the same platform. Does that make sense? Okay. I know it's not really exciting. So ArcSight has dashboards and retention. This is really like arts and crafts for managers. I swear, because that's all they really care about for a lot of times, right? So when the C-level comes down to you, they don't need to know every single event. They want to see a chart. Like, why am I here? You have them for 10 minutes, you have to sell them in 10 minutes. So ArcSight is a way to take that data, those logs, and give value to those logs. So these are some of the graphs or dashboards that you can get out of ArcSight. You can see right there we have, in that upper left-hand corner there, it's a VPN graph. So it's everyone that's VPN'd into the company. So that's VPN logs. And the right-hand side there, there's dashboards, and that's just another way to frame out logs. But these logs can have better, more value. So the logs alone are good, but then you have to add value to those logs. You do that through rules. So right here, you guys have to follow along there. Oh, actually, I'm just going to put here. It's really hard to see. I wish it was a little clearer. But so these are vulnerabilities. This is what ArcSight uses as a graph view of a rule. So these are vulnerabilities. These can come from Retina, Nessus, Wallace, whatever scanning tool you're using. These are vulnerabilities that are imported. This is a rule. This rule feeds another rule, which then can feed an active channel. So an active list. So you can put all your trusted hosts into one list. And then from that trusted list, you might say things that aren't vulnerable, or items that aren't running an application, or that trusted list can contain literally every single Windows device in your entire network. Or maybe in that trusted list might contain all your scanning hosts, all your vulnerability scanners in your network, and things you don't want to alert on, but it's there. Take these vulnerabilities, apply them to a list, and say if I see this vulnerability and this event happens, and it's vulnerable, fire me an alert. So if I can look at it that way, it's a little different. So if I have an IDS alert that fires on a system that isn't vulnerable, I don't want to know about it, right? Otherwise, you get woken up in the middle of the night for a big vulnerability that's something that's not vulnerable to, right? It makes sense. So a lot of people will use a third-party ticketing system. HP actually has Service Manager, and then there's also BMC Remedy, which a lot of people in the DoD use. But ArcSight has it built in, so it's all here. ArcSight can literally do, I think, everything in the security environment needs to be done. As far as the correlation of logs, the working of tickets, it can all be done in ArcSight. But I say that, and I think it's a great tool, but there's pros and cons. Yes. I only worked on this presentation for about 40 minutes, so I was really happy that was the next slide. So, the pros, it's customizable. Like I said earlier, you can build a Flex connector and get any log you want into ArcSight. Yeah, it's going to take some time. Sometimes a lot of time. But it's okay, because once it's in there, it's good to go. Another pro to it is the manager interface. There's 3 different interfaces to ArcSight. There's the command center, which is where you're going to see things like this. You can also see that in the web console. And then there's the logger, which logger is just like Splunk, except ArcSight does something a little different. It uses the common event format, so when ArcSight pulls in your data, let's see if I can get the right slide here, right there. So when ArcSight pulls in that data, it's going to normalize that data, and it's going to give it fields. So your host field is actually going to be a host now. So when it's pulling in all these different fields, that's one of the most powerful things about ArcSight, is that I can write one rule that looks for one specific field across my entire environment. So what that'll end up doing for you is allowing you to make smaller rules more efficient across your entire environment. So then you have the logger, and so the logger, going back to that common event format, let's see if I can get it here. There you go. Common event format allows you to run SQL-like commands against all the entire logs in your entire system, entire network. That's going to be really helpful for you, I promise, when you start correlating the events. Because it runs about, I've seen it go through about 5 billion logs in about 10 minutes. So 5 billion logs is a lot. No human can do that. It'd be pretty impressive. And I'm not talking just syslogs. So it can chew through a lot of stuff, especially if you're using just specific fields. So let me get to the demo-ish portion. Because I'm using like my company's own ArcSight platform here, I had to choose some things that were very specific that weren't going to disclose any information. So just move to some pretty basic things that you could do pretty quickly. This is NetFlow data. So it's not true NetFlow data. It's just a way for us to monitor network traffic in and out of the network. So while you can access NetFlow data, you can very well pipe things from Riverbed, or you could pipe things out of any of your your capture devices into ArcSight and just pipe in like maybe a packet capture. You can do that. ArcSight can do packet capture. It's not going to be wonderful, but it can do it. But you can also just maybe get bytes in, bytes out of your network. Maybe that's something you want to do. It can be done here as well. So this right here is just in and outbound traffic for the network using firewall. It's a very easy to view graph. It's going to be almost real time, near real time, and it's going to allow you to see the spikes. So I think there's some spikes on here. This is captured from this afternoon. So we have a spike right here that would normally just get somebody's attention, right? If you saw that and you're just sitting there, you'd be like, what is that? So that's a problem. And you kind of alert to it. And you also get a good idea of the baseline. We talked about it a little earlier, it's like just determining like what's normal in your network. Because a lot of people don't know what's normal. And so you end up, when someone actually pokes and prods at you, if someone walks into your department and says, hey, is this normal? you're looking at it, and you haven't looked at it in about 3 months, and you're like, I don't know if that's normal, I have no idea. And so you start looking at it, and you feel like your hair's on fire because you're getting poked and prodded. But this will allow you to look at it and be like, well, I know it's normal because I have a log that goes back 6 months, and I know what it looks like 6 months ago. So that's something you can do. Tor traffic's an easy one. You can always import Tor traffic. I ran this back 6 months to see where we were communicating Tor traffic. And this is what it looks like. So this is the top 50 Tor traffic users for the last 6 months, or Tor traffic destinations. You guys really can't see this down here, but most of this is DuckDuckGo and their domains. And I tried to put this up here so you guys can see, but it's really not coming through very well. But this is the graph, like I said. So what you can do in ArcSight when you get in there, when you start building this content, it sits on top of each other. It's very easy to get lost in the sauce of your own content. So what you got to do, what you try to do is build these filters, build these rules that you can constantly reuse and rehash. Maybe you want to look for VPN logins as one rule, but then take that VPN login, and I only want to look at VPN logins from another country. So then I want to look at VPN logins from a suspicious country, countries I don't do business with now. And you keep building on top of these rules so that you can constantly reference that same rule over and over again. Because when a rule fires, it creates its own event, just like a log event. So you can look at that event to reference another event. And you can pass fields over so that you can continue to look at them over and over again, using that common event format. Is that super exciting, I know, but it's really cool to see 6 months down the line, because you have to kind of anticipate what you think someone's going to need from you. Because if you don't want to trend every single event that comes in. So if I wanted to maintain those 6 billion events, how long do I want to retain them for? Is it 2 years? Is it 3 years? Some places you need to maintain them for 6 years. It just depends on the kind of log and what kind of data restrictions you're using. This is external attackers from a known bad source. Again, you guys can see this is a pretty big chunk. It's a lot of reused content, but it's good because it's content you're going to use on a regular basis. That's Alien Vault data. So we're just importing the entire Alien Vault OTX into our ArcSight because it's, one, free, and it's threat intel that we can use over and over and over again. So right here is the top talkers to us for the 2 hours at the top, and then 12 hours beneath that. So when someone walks in, we can say, well, this is what's happening right now, and this is what happened in the last day. And we can go back farther if we need to. So this is me. I'm on Twitter. It's at @IamHamSandwich. I just went through a name change. I was at the Blue Falcon, or the Falcon Blue. I wanted to have a better security name, because everyone has these great security names. And I was like, Ham Sandwich, that sounds really cool, but of course it's taken. So I Am Ham Sandwich was the next best thing. I'm on LinkedIn. I have a really robust profile. I have a good picture and everything. It's up there. I really don't ever check it. And I am looking for a threat intel analyst and a malware reverse engineer in the next 6 months or so. So if you guys know of anybody or you're interested, please reach out to me. I think the pay is really good. I think it's okay, especially for the area. And I think we're a great bunch of guys to work with. So, does anyone have any questions about ArcSight? Or I can tell I'm losing a couple of people. No? No? I got nothing?
So does it store all of that stuff, all the logs?
So it's a good question. So ArcSight has a really interesting architecture from just an ArcSight appliances piece. So the logger is what stores the logs, and it can store the logs. It has a 4 terabyte, and you can attach it to as a 12 terabyte. I'm sorry, this is a different version, but you can attach it to a SAN storage or LUN, and you can archive out as long as you want. You can keep going and going and going. But so normally it stores for about 90 days, and then it starts to squish to just compress all the logs, and you can dump it back as long as you want. So it's just up to you. So and you can actually have it feed in different manners. So it can feed to what's the ESM, that's what's going to go with correlation. Or it can then to the logger, or it can feed to the logger and then to the correlation engine. It's whatever you want, just where you want the logs first. Yeah. Any other questions? I could talk about each one of these blocks for an hour apiece, I swear. So I mean, if you don't have any questions, don't worry about it. You can always hit me up on Twitter, and I'd love to talk about this stuff. I love it so much. I didn't know anything about it about a year ago, and I got certified in it. So pretty cool. All right. Thanks, guys. I appreciate it. I wasn't kidding about the Blue Falcon either, so here it is. Thanks. Oh, no, this is mine. I brought it with me.
All right, one more time for our second half of speakers here. I like that talk. Makes me a nerd, so that's fun. Yeah, so Pivot Community Night one more time. If you do want to hear Kris talk for hours on end about log correlation, come to the community night. It's a riot. Seriously though, Kris is a regular at our community nights. It's a great time. I encourage you all to come out. What do you guys feel about tonight? I like this, man. I think we should do this again. So those of you that didn't talk tonight, I think you got a good idea what's going on. You know, just something you're playing with, just a tool that you use every day at work. Maybe something that screwed you over, but you want to share with everybody. Let it out, man. Good stuff all around. Anybody here going to besides Cleveland? Maybe some of you? Yeah, we're going to be there. So hopefully we'll see you all there. The next CleveSec meeting is just before then, so we'll also see you with that. Until next time, thanks for coming out, guys.